So in this slide, we're going to talk more about atmospheric type pollution, but first we have to give a little bit of background information. So down here at the bottom, I've drawn out sort of a representation of the Earth right here, and then I've kind of divided up the atmosphere into little zones here. The first one being the troposphere, then the stratosphere, mesosphere here, and then the thermosphere. And each one of these little zones has different properties. And for our environmental science, we're concerned about in the troposphere contains the bulk of the carbon dioxide, and then in the stratosphere is where the bulk of the ozone is located, okay? And ozone is made from lightning or sunlight in combination with oxygen. Oxygen. And here I've drawn out the sun, okay? And it's sending out light, okay? And what you and I can see is visible light, which I've shown right here. But it's producing actually a lot more than just visible light. And you may have heard, put on your sunscreen to block UV light, because that's a different thing. So here I've shown what is the electromagnetic, spectrum. And I'm sure you guys have used a radio, and so radio waves is a low energy electromagnetic radiation. And then we have IR, which is you could think of as heat. When you stand out in the sun, you get hot. And then we have the visible light. And then we have UV, which what we talked about. And then if you go to the dentist or or a doctor and you get X-rays, that's even a higher energy than UV. And then we have gamma rays, which are even higher, which usually you don't see unless you're doing some nuclear type transitions. But the sun doesn't produce all of these evenly. And if you look at the sun spectrum, and I've taken this off of, I think, Wikipedia, this is the spectrum that the sun puts out. And like I said down here, the axis is wavelength and nanometers. And you don't need to really know that. All you really need to know is that large wavelength numbers is low energy and small wavelengths is high energy, okay? And so this is the spectrum that is actually being produced. So you can see there's some UV in here, and it actually shows you in the chart here that it's mostly being blocked out by ozone. Ozone being O3. That's the symbol that scientists use for ozone. And then we have visible, and then IR. A lot of it's getting absorbed by water and CO2. So we have the sun here, and it's sending out the infrared light. That's part of it. This long tail right here. See, it says infrared, and there's this long tail of infrared. And the infrared hits the Earth, and it gets reflected back. But the carbon dioxide absorbs the light and warms up the Earth. And you want some to be there, because if there was no carbon dioxide, the Earth would just be frozen over, a solid block of ice. But carbon dioxide is what's called a greenhouse gas, because it's absorbing some of the infrared, that's IR. So in this one here, they've called it IR, but that stands for infrared right here. Whoops. And so that absorbs the heat. And remember, infrared is basically heat. So the infrared comes down, hits the Earth, some of it gets reflected back, and the carbon dioxide absorbs it and warms up. And you want some of that to happen. But too much of it, and what you hear is, you burn fossil fuels, and in that process of fuel plus oxygen, and you burn it, you get water and carbon dioxide, okay? And carbon dioxide is a greenhouse gas. It absorbs the infrared radiation coming from the sun. The other part here is the ozone, which I talked about, and that's in the stratosphere, and you may have heard about the ozone layer. And it's needed because this ultraviolet radiation that the sun is producing in this region right here is harmful to humans. And it can cause cancer and destroy cells. And so a lot of it is being blocked out by the ozone that's in the stratosphere. And here I've just sort of if you want to go a little bit deeper, you can totally skip over this if you want to. I have the periodic table of elements. So everything is made up of an element off of the periodic table of elements. Say if you have water, you probably already know that it's composed of 2 hydrogens and an oxygen. So we call it H2O, okay? And so oxygen normally exists in the atmosphere, what we would call as 2 atoms bonded together of oxygen. And then ozone is 3 atoms of oxygen bonded together. So here is one of those terms that you need to define. Ozone is a substance in the stratosphere that prevents harmful ultraviolet radiation, or you could say light, from reaching the Earth, okay? And so that's why ozone is important. Let's see. And I just put in here that not all pollutants are man-made. I mean, living in Nevada, you know forest fires. Last summer of 2021, we had almost 3 months of smoke. And volcanoes produce pollutants, and algae can produce pollutants as they die and decompose. But for our atmospheric case, the major source is burning of fossil fuels for humans. So now we're going to switch over to acid rain. So what is acid rain? First, we need to talk about acidity. Acidity is a property of liquids. A liquid has some acidity value, and it's reported as pH. That's what we call it. You say the pH of this liquid is 7. The pH of this liquid is 4. And so on this next slide, well, a couple slides down. So here I've given a pH scale. And so we call something neutral if it has a pH equal to 7. Okay? And if it's very acidic, then it's going to have a low pH, like battery acid here, they say pH equal to 0. And if it's very basic, so down here we call acidic if it's less than 7. And we call it basic if it's greater than 7. So baking soda that you might use for cooking, or seawater is 8, or bleach that you might use for your cleaner has a pH of around 13.5. So that's all you really need. pH 7 is like water that's very pure, is 7. And then acids have low pH, bases have high pH, okay? That's all you really need to worry about. And so the focus of this part was acid rain, okay? And so where does acid rain come from? So rain is slightly acidic at a pH of 5.6, so that's less than 7. Pure water would be a pH of 7, but it absorbs carbon dioxide from the air and forms what's called carbonic acid, which makes the rain acidic. So why is rain slightly acidic at pH 5.6? Because it has carbonic acid in it. So when we're talking about acid rain, we're not talking about the slightly natural acidic rain, the 5.6, but the more acidic rain caused by burning of coal, oil, diesel, and gasolines and things like that. Because the burning of fuels releases sulfur dioxide and various nitrogen oxides, okay? And remember, CO2 carbon dioxide reacted with the water in the air to form carbonic acid. Then we have these sulfur dioxide and nitrogen oxides reacting with the water in the air and forming sulfuric and nitric acid. And these are much stronger, have lower pH acids. So rainwater will have a pH of less than 5 as if it's acid rain, okay? So these nitric and sulfuric acids are bad because for plants, because they remove nutrients from the plants out of the soil, such as calcium and magnesium. The acid rain will also make the plant more susceptible to environmental stress. So if it gets too cold, or we have a drought, or it's too hot, if the plant has had acid rain on it, it's more likely to die. And I just put this in here too. There are also natural sources of nitric and sulfuric acid. So lightning, because the air is 78% nitrogen, and lightning will cause nitric oxides to form, which will then form, the nitric acid. And volcanoes can release sulfur dioxide, which will go to the sulfuric acid. And so man-made sources of acid rain exist, and there's also some natural sources of acid rain. And so this part talks about global warming. So some scientists believe that the release of greenhouse gases, remember that we talked about burning of fuels releases carbon dioxide. So some scientists believe the release of greenhouse gases have led to the increase of the Earth's temperature. And so, as I said before, greenhouse gases are gases that trap the sun's heat near the Earth's surface. A little bit is okay, but a lot, maybe not so okay. And carbon dioxide can come from fires, forest fires, or burning fuels, And so, and then I put here also methane is a greenhouse gas. So these are all right here, different greenhouse gases. So carbon dioxide from fires and burning fuels, methane from garbage dumps. As things decompose, the bacteria release methane. And the same thing with cows. As cows are eating their food, there's bacteria in their stomachs that digest this grass, and it produces methane. And methane retains 20 times more heat than carbon dioxide. And then we have nitrous oxide from fires, burning fuels, and the breakdown of nitrogen fertilizers. It will retain 230 times more heat. And then we have something called chlorofluorocarbons, which are propellants used in aerosol cans. They can retain 1,000 times or more heat than carbon dioxide. And then this last part talks about ozone, okay? And CFC, so those chlorofluorohydrocarbons, okay? And as I showed you in that diagram of the Earth, where we had the troposphere, then the stratosphere, and that was where the ozone was at, okay, out here. And so I said the ozone layer is around 9 to 22 miles from the Earth's surface, and the ozone layer absorbs between 97 and 99% of the ultraviolet radiation that's reaching the Earth. So I put in the nanometers, but you could just say high energy radiation from the sun. So the ozone layer absorbs between 97 and 99% of the high energy radiation coming from the sun. Now, again, these CFCs were used, but they're now banned in aerosol cans as a propellant. And it was believed that that destroys the ozone layer, and that's a bad thing because without the ozone layer, harmful UV radiation would reach the Earth's surface, causing damage to cells of all living things.